All right, good afternoon, ladies and gentlemen. So our objective for today is that students will be able to determine the decay factor of an exponential relationship given the rate of decay and vice versa, right? So we're starting to talk more about exponential decay, which is an exponential relationship where things are getting smaller, or we say that they're decaying or they're decreasing, right? So in the past, when we talked about exponential relationships, we talked about something called the growth factor, and we also saw something called the growth rate. So remember, the growth factor tells us what number you're multiplying by, while the growth rate tells us by what percentage the value is increasing by. So just to refresh your memory really quickly, here's a quick example. This is an exponential relationship. The years are on the left, the value is on the right. It is increasing, so I know that it's growing. To find the growth factor, it's 1.03. Just remember, the way that we find that is I look at one value, I divide it by the value above it, because I'm trying to figure out what number did I multiply 100 by to get 103. So all I would have to do is 103 divided by 100, and I get 1.03. That's the growth factor, because 100 multiplied by 1.03, right? 100 times 1.03 gives me the next thing in my table. And again, if I again multiplied by 1.03 again, I would get down to this. Multiplied by 1.03 again, I get down to this. So my growth factor is 1.03. Now the growth rate, remember we did that conversion before, in this case is 3%, because I'm focusing on the decimal portion. This tells me by what percentage I increased. So 3% of 100 is 3, so this from here to here increased by 3%. Now, we have something similar when we're talking about exponential decay. So we have decay factors, and we have a rate of decay. That's the same thing, similar to a growth rate. Instead of saying a decay rate, we say rate of decay. So I'm gonna walk you through this with an example. So first off, it's saying that the value of a car typically depreciates or decreases over time, right? So you start driving a car, it gets dings and scratches on it, the engine gets used, so the value starts to diminish over time. Now, the table to the right shows the value of the car, right? So I can see that it is obviously decreasing. It starts at $30,000. After 5 years, it's down to only $13,000. So the value is not increasing, it's decreasing. Now, if I want to find the decay factor, I'm going to find that the same exact way that we would find the growth rate. So to find the decay factor, sorry, the growth factor. To find the decay factor, I'm going to take one item, divide it by the one directly above it. That's going to tell me, because what I'm looking for is what number times 37,000 gives me 25,500. So 25,500 divided by 30,000 gives me a decay factor of 0.85. So my decay factor here is 0.85. Again, what that tells you, that's the number that I multiply by this number to get to this. And then if again, I want to multiply 25,500 times that decay factor of 0.85, 21,675 is the next number that I have here. So that's telling me what do I keep multiplying by to move down this table. What is the rate of decay? And just to explain what the rate of decay is, it says by what percentage did the car's value decrease by every year? So based on what we did with growth rates and growth factors, you might think, okay, that's going to be 85%, right? But we have to think about this. Did the value of the car decrease by 85%, right? 85% of this car is going to be a lot of money, right? Just think more about half of this, right? Half the value of this car is $15,000. So if this was to decrease by 85%, that means that this should be worth less than half. But right now, it's not worth less than half. It only dropped by about $4,500, right? Which is nowhere near 85%. So it's a little bit different when we talk about rates of decay. In this case here, this 85%, what it represents is how much of the car's value is left over. So from year 0 to year 1, the car retained 85% of its value, which means that it actually decreased by 15%, right? Because 85% plus 15% gets us to 100%. So just to kind of show that to you, right? If I did 30,000 multiplied by 15%, that's the $4,500 that the car's value decreased by. So you need to be careful when you talk about your rates of decay. It's kind of the opposite of the decay factor. So that's what you're going to practice today, right? Over here on part 2 are some steps that you can use to do that. I outlined them for you. It says step 1, convert your decay factor to a percentage first, and then subtract that percentage from 100%. So for this example here, I'm saying that the decay factor is 0.90. If I want to convert that to a percentage, I divide that by 100. That would give me 90%. But remember, that's how much of the value is retained. So this actually represents a decrease of 100% minus 90%, or 10%. So 10% plus 90 gets me to that 100%. So again, be careful. It's kind of the opposite of what you see here. Don't get fooled. Now, you're going to do the same thing for these examples here. I gave you the decay factors on the left. You're going to provide the rates of decay on the right-hand side. Remember, they should be percentages, so all these values should have percentages attached to them. After that, on the next part, you're going to do the reverse. So instead of me telling you how to do that, based on what we did here, I want you to first write out in words, how would that process work? What are you going to do to these numbers to get your decay factor? And then I want you to practice that. All right? If you have any questions, the Zoom session will be open at the regular time. Good luck.